In this video, we're going to continue on with the notes characteristics of polynomials. So we're continuing here on the last piece of paper on the front there, and we're doing questions 15 through 22. I want to match each equation to its graph. So if I'm looking right here, the type of equation I have is a first degree equation because the exponent is a 1. So this should make a line shape. I also realize it has a negative out in front, so I should have some sort of graph that looks like a line going down. The only option for that is F. And I can see that also corresponds because the y-intercept was 3, and I had a 3 here on the end of the equation. So the answer to number 15 is F. All right, number 16, we have an x squared equation, which means I should make a U shape going up. There's only one U shape going up, and that's H. On number 17, I have a negative leading coefficient, and I'm an x squared. So I should be a U shape, and I should be going down. The only option for that one is C. So the answer to 17 is C. Sorry, I keep popping things up at the bottom. This is not my usual computer. Number 18, I have a positive leading coefficient, and I'm a cubed. Remember, a regular cubed would just look like a bendy shape, but my cubed might have some bumps in it. Either way, I'm going to start and end in different directions, and I'm going to end up in the air like I do right here in A. That's my only option for one that makes the cubic shape that ends up like that. All right, number 19, I have a fourth degree function, which should make a U or a W shape, and the negative out in front tells me that this thing is upside down. So I need to make some sort of upside down U, which my answer choice for that would be E. Number 20 is a negative again, and this one is a third degree function. So a third degree function has to start and end in different directions, and because it's negative, it's flipped over, so it's going to end down, and then it would make it start up. My option for that is D. Number 21 is a fourth degree function, so I should make a U or a W shape. It's positive leading coefficient, so it needs to be going up in the air, and that would be shape G here. Number 22 is a positive leading coefficient, and it's an x to the fifth function. So it needs to start and end in different directions. It's positive, so it's going to end up. What happens in between here could be a couple of things. We could have up to 4 turns in there because that's a fifth degree function. And I can see this one that I have up here in B is the one that has all these different turning points. 1, 2, 3, 4 turning points. So that has to be at least a fifth degree function. So my only option for B is to put it in spot number 22. So notice I didn't actually have to go through and graph any of these on my calculator. I could have done that to check, and if it were an SOL test or something, I would have, but I can get the idea of the general shape without doing that. 22 and 23 are just, 23 and 24 are some thinking questions. Is it possible that a polynomial with an odd degree can have no real roots? Well, because an odd function starts and ends in different directions, I can make it have as many roots as I want to depending on the degree, but no matter how much I move this thing up or down, since the range is all real numbers, it's always going to cross the x-axis somewhere. So it is not possible that a polynomial with odd degree can have no real roots. The other reason we could say this is we know that imaginaries have to come in even pairs because there's always a plus minus pair, and an odd degree has to have an odd number of zeros, so at least one of them will have to be real. All right, number 24 says, is it possible that a polynomial with an even degree can have no real roots? And the answer to that is definitely yes. Even if we have a big fourth, fifth, or sixth degree function, so long as the whole thing is above or below the axis, sorry, there's baby shot, it's going to have no real roots. All right, next we're going to look at how we can sketch polynomials without using a calculator. We're going to use the same ideas we've been using to look at the graphs, But let's just look if we started with this equation. Now I've got two versions of the equation. I have this first one right here, which is in standard form, y equals x cubed minus 3x minus 2. And then over here I have the factored form of the equation. We can tell different things from both of them. I like the factored form the best, I think, because it starts out and I can see that if I have x plus 1 with a multiplicity of 2, that means that x equals negative 1 is going to be a 0, because when I set the factor equal to 0, I would subtract 1 to move it over, which will give me x is negative 1, and the 2 in the exponent for the factor tells me the multiplicity is 2. Now, I could go and put a point on my x-axis at negative 1. The fact that there's a multiplicity of 2, though, tells me it's going to look like a U shape there. It's going to look like an x squared when it touches. So it's going to make a U shape. The only problem with trying to draw it on from the start is I don't know whether it's going to be a U shape going up or down, so I can't go any further just yet. Let's get some more information. I also have a factor of x minus 2. If I have a factor of x minus 2 and I set it equal to 0, when I add 2 to move that over, I get x equals 2 is another x-intercept, or 0 or root, however you want to call it. This one did not have an exponent, so I know that when I go straight through, it's going to look like a line. It's going to just cross and go straight through. All right. From my equation that was written in standard form, I can tell by the constant on the end that I'm going to have a y-intercept of 0, negative 2. So I could plot that point on there. What else do I know? Well, I know that I have a third degree function. If I have a third degree function, let me write down the degree, 3, then that tells me that it's also a positive leading coefficient, so my right end behavior should be up in the air, and because it's an odd power, I know my left end needs to go the other direction, so my left end should be pointing down. So when I'm graphing, I know that my right end needs to start up, my left end needs to point down, and now I just need to go through and connect the dots. So I was starting out from the bottom. When I get to the 0 at negative 1, it has to be a turning point because that had a multiplicity of 2. Somewhere I need to turn around and then go up through my 0 at positive 2. Depending on where you made your graph, your turn might not be down here, but there has to be one turn, and that's it to get back to that other x-intercept. Okay, let's try another one. If we turn the page, we have another example where I haven't filled in the sketch yet. So let's see what this one tells us. Well, I can see from my first factor right here is negative x squared. If I take my negative x squared and I set it equal to 0, I can divide by negative to get rid of the negative. I can square root to get rid of the 2, but that's still going to give me x equals 0. So my x equals 0, though, has a multiplicity of 2, which means I'm going to make a U shape for that 0. I also have a factor of x plus 3. If I set x plus 3 equal to 0, that's going to give me a 0 at negative 3. That one has an exponent of 1, so it's a multiplicity of 1. It's just going to look like a line when it crosses the x-axis. At x minus 4, if I set that factor equal to 0, it gives me x equals 4 is a 0. That factor has a power of 3, so the multiplicity is 3, which tells me that I'm going to make a cubic bend shape when I cross the x-axis. Now remember, I don't know, it depends whether I'm coming from the top or the bottom, whether my bend is going to go up, down, or my U also might be upside down. I don't know until I get to them. I'm going to have to do the end behavior before I can figure that out. All right, so let's see what else I know. If I want to figure out what the y-intercept of this function is, I would normally want to look at it in standard form. My function's not written in standard form right now. All I really care about from standard form is my first term, that's my leading coefficient, and then I care about what kind of constant I have down here on the end, because that's going to give me my y-intercept. So I'm not going to worry about actually multiplying all this stuff together. That would take me a while. I'm just going to think about what I'd get. For the biggest power, I'd start out, I'd have my negative x squared. I'd have another x, so now I'd be up to negative x cubed, and then I'd have 3 more x's from this one, so I'd be at negative x to the 6th is going to be how this thing starts. I'll have a whole bunch of stuff in the middle that I don't really care about. On the end, as far as getting a constant, because I have this negative x squared out in front, all of my terms are going to have x's with them, so my constant on the end must be 0. So my y-intercept is 0. I could also tell that because if the x-intercept is 0, the y-intercept has to be 0 as well. All right, let's go ahead and plot those zeros because I didn't plot them yet. That might have helped me. So there's my x and y-intercept right there at 0. I have another one over here at negative 3. And I have another one over here at positive 4. I also needed the degree of this function, which was going to be this 6 up here. So it's a 6th degree function. That tells me that my ends are going to go the same direction, right? So I've got to think about my right end behavior. I can tell that by my leading coefficient. This is negative, so I know this thing has been flipped over. So my right end is going to go down, which means my left end is also going to go down. And I know if I'm over here doing my graph that these two ends need to go down. Now I can start with either direction. It doesn't really matter. And I'm going to think as I approach the x-axis there of what shape I need to be. My 0 at negative 3 had to look like a line when it crossed. So as I come up here, I'm just going to draw that straight through. Now, in order to get back to the 0 at the origin, I'm going to have to somewhere turn around. How far up you go doesn't really matter. Notice my graph doesn't have any sort of y-scale. All right. Now my next 0 is at x equals 0. That has a multiplicity of 2. So this has to be a turning point at the origin. Since I was coming from the top, my u has to be facing up. Now again, I'm going to have to turn around to get to my 0 over here at 4. My 0 at 4 has to make a turning point. So it's going to bend. It could either bend this way, but that's not going to connect and make a function, or it could bend the other direction, which is what I'm going to have to do to make this thing make a function. And then it was also supposed to line up with that other point, so I'm just going to scooch it over. All right, so go back at the end and say, does this all make sense? I have my 3 zeros where I'm supposed to have. I have the correct multiplicity in the shape. I have both ends going down, and that was what I wanted. So everything looks good. So now it would be a good idea if you pause the video while you try number 25, 26, and 27, and then check back. Remember, these are sketches. They're not like meticulous perfect graphs. I didn't give you a grid. So you can do your sketch based on general behaviors, and then we'll go from there. So when you're finished, unpause the video and you can check how you did. Okay, number 25. On this one, we have 3 factors. So this first factor is going to give me a 0 at negative 2. The second factor is going to give me a 0 at negative 5. Now this one I have to be careful of. That one has a multiplicity of 2. It has an exponent of 2, so it has to make a U shape, either up or down, depending which way I come. And then my last 0 is going to be at x equals 3. And that one is a multiplicity of 3 because it has a 3 in the exponent. So that's got to make a bendy shape one way or the other where it touches the axis. Okay, now I need to think about the end behavior of this thing. Overall, the whole thing was positive. There was no negative out in front. So I know it needs to end up in the air. If I thought about counting up the exponents, I would have 1x there, 2 x's here, and 3 more in the last one. So this is a 6th degree function, so that I know it needs to start and end in the same direction. I might have all kinds of craziness in between, but I know that I'm going to start and end in the same direction. So I can really start at either end. I'm going to go ahead and start from left to right. So I'm starting out up at the top. As I get close to my x-axis right here, I have to make a U shape at negative 5. Then I get close to my 0 at x equals negative 2. That one didn't have a multiplicity, so I have to cross through. Then I'm going to have to turn around to get to my 0 here at x equals 3. I think in general you guys do better if you start on the, start on the point and then draw it from there. That helps make your bend shape. okay? And everything should be nice and smooth in between. All right, number 26, we started out this one. It had a negative leading coefficient, so I know that over here on the right I'm going to end down. I could also think about the degree if I want to figure out where I started. I've got 1x here, another one makes 2, 2 more makes 4, and 1 more makes 5, so this is a 5th degree function, so I know it's got to start and end in different directions, so this one's going to start up in the air. All right, let's look at where all the zeros are. I have a 0 at x equals 0, and that's going to have a multiplicity of 1 because there's no exponent with that factor. I have a 0 at x equals negative 4, which is also a multiplicity of 1, so it's going to go straight through because there's no exponent. I have a 0 at x equals negative 2. Now that one has a multiplicity of 2 in the exponent, so I know that this one has to make a U shape. It could either go up or down. I don't really know yet. We'll wait and see. I have a 0 at x equals positive 3, and that's going to go straight on through as well. All right, so let's go through and connect the dots. I'm going to start from left to right like I was. I was up here, and now I'm going to come through. I'm going to go straight through. Sorry, my pen's going crazy on me. I'm going to go straight through. Then I've got to turn to get back to this blue one. The blue one has to make a U shape because that was a squared exponent. Then I've got to turn to get back through the origin. That one's got to go straight through because that was a power 1. Then I've got to turn to get back through this black one over here, and that's again a multiplicity of 1. So I know I drew this original arrow. I'm going to erase that one since I was a little over to the left. It doesn't matter. It's not a perfect graph. It's just seeing the general shape of this thing. Also, when we're graphing, as far as which bump comes down further, you know, this bump or this bump, it doesn't really matter. If you made yours come way down here, that would be okay as well. All right, last one, number 27, said sketch a polynomial with negative leading coefficient. So a negative leading coefficient tells me that I've got to end down on the right side. I have to have real zeros at x equals 2. I'll put one of those on. At x equals negative 3. I'll put that one on. Oh, now my 0 at x equals negative 3 has a multiplicity of 2. So this one right here has to make a U shape, right? That's either going to be an upward U or a downward U. I don't know yet. I also have to have 2 complex zeros with imaginary components. So this means I have to make a bump that could touch the x-axis but doesn't. Okay, where it happens, it doesn't really matter. So if I'm looking at this right now, what power do I have? If I need to start down here on the bottom, I need to start down. So I'm going to come up, I'm going to cross. In order to get to this 0 at negative 3, I'm going to have to make a U shape. Now the only thing I haven't dealt with yet is I haven't dealt with my extra bend. I'm just going to do that right here. I've got to make a turn that comes down. And this turn right here, if I had made it lower for that turn, it would have touched the x-axis, but I made it not touch the x-axis. Let me get my other stuff out of the way here. Oops, not that one. That one back. Get this purple one out of the way. So anywhere you made that extra bump would be fine. So here's an example where I made my extra bump in between the 2 zeros. Or the other thing I could have done is I could have made my 0 at negative 3, my 0 at positive 2. I could start up, turn, come back, and then down here I could make a bend that had the option of going up and touching the x-axis but didn't. So any of those would all be good graphs. But all of our graphs have to start out up on the left and they have to end down on the right. That's important because that's that negative leading coefficient part. They all have to have these x-intercepts, and it has to happen that the x-intercept at negative 3 is a turn point and the x-intercept at 2 is a go straight through point. Then somewhere I have to have this extra bump that could touch the x-axis but did not. Okay, thanks, and let us know what questions you have in class.